Hey everyone, so I am Chloe McAree. I have been an AWS Community Builder for around 4 years now, and I am a senior software engineer at Hamilton Robson. So at Hamilton Robson, we are a technology company that specialises in software services, but also immersive AV experiences. Working with customers like X, Reddit, Warner Brothers, and Salesforce has allowed us to work on both unique creative projects, but also scalable enterprise projects. Well, today I am here to talk to you about AWS Step Functions. So before I get too excited and dive straight into state functions, state definitions and step functions, I want to start right back at the start of the customer, the project, the problems we were facing, and why we decided to ultimately use step functions. So let's start with the client. We were working with a client to build a recruitment platform within the construction sector. So this application will allow workers to match with jobs based on things like their location, proximity to the job site, their experience, their skills, and their salary expectation. So before they could actually match and join a job and turn up on job site, we had to collect a number of different documents from them. And this was just to overall proof their identity and also their right to work in the UK. So originally, once we started the project, we just needed to collect these 3 documents. Don't worry, these are dummy documents. There's no PII exposed here. But we had to collect a passport and a CSCS card. So if you're unfamiliar with that, that's a construction skills certification scheme. So you get them for different trades, like the one on the screen is for labourer, there'll be one for bricklaying, and just all of the different trades. Then we also needed to collect a P45 or P60 for proof of national insurance. So when we started the project, all of these documents were mandatory to collect. And this was our original implementation. So once a worker onboarded, we would then create a message to an SQS queue that would contain things like the image URL for their passport, image URL for their national insurance document, and image URL for their CSCS card. This document validation lambda would then parse that SQS message and would then subsequently invoke the individual lambdas. So those individual document lambdas contain different and specific AI check-in services and rules specific to that individual document. And the document validation service would then wait for those responses to come back and would run continuity checks across them. It was pretty simple and it did work. But when you have a live system, it's always going to grow, it's always going to change, and client requirements always do change. So CSCS card was the first to become optional. We would have workers who were trainees and they wouldn't have that document. Then national insurance number image upload also became optional. Workers were able to manually enter it and prove their national insurance number that way. Finally, passport also became optional. And this then resulted in us having 7 different possible permutations of document combinations that could be uploaded to the system. So you could potentially have all 3 documents, any combination of 2 documents, or just 1 document. And of course, we went into the document validation service Lambda. We started just adding some if-else statements in there. If the URL was present, let's invoke that Lambda. If it was present as well, we would get those results and we would compare them. And again, still working until more requirements came in. We now had to support 2 more documents, driving license and visas, resulting in, I think that is 26 possible permutations of the different document combinations that could be uploaded to the system. So any combination, all 5, any combination of 4 of them, any combination of 3, combination of 2, are the individual documents. So I know what you're thinking. Let's just throw some more if-else statements in there and be done with it. And whenever we actually look, if we were to do that, this document validation service Lambda, it just starts to become the bottleneck here. We are synchronously calling out to these different Lambdas, waiting for that response to come back. The more documents that we start to scale, the runtime of this document validation service was going to start to grow exponentially. That was going to be the bottleneck. And it really makes me think back to a quote I heard at reInvent last year by Eric Johnson. He said, if a lambda should be used to transform and not only to transport. And when thinking about our use case, we were really just starting to use so much if-else logic to understand what needed to be triggered downstream. And in his talk, he had said, if you're just using it to transport logic or trigger downstream functionality, you should consider step functions. So this is what led us into this talk today. How could we utilize step functions and could they work for this use case? So if you're not familiar, step functions are a serverless orchestration service. They manage input, output, they handle errors and also retries. With step functions built-in controls, you can examine the state at each step of your workflow and make sure that your application is running in order and as expected. So here's an example of some of the different flows that you can have in your step function state machines. So we start off at the top with a choice state. So this is your traditional if-else. So if something is present, we'll go down one branch. If it's not, we'll go down the other branch. We move into parallel processing. So these are separate branches that can all process at the same time, and then you can make sure that you can combine those results after. We have a map that can run parallel workflows over each item in a data set. We have our path state, which can transform data and act like a placeholder. We have our wait that allows you to insert different delays into your step function state machines. And at the end, then we also have the success and fail states. So they allow you to just stop processing and just mark it either as a success or a fail. So when I was looking at all of these different flows, these possibilities, and how you kind of move through different branches, it always makes me think back to those different flow magazine quizzes you would do when you were younger. So, you know, you start at the top, you kind of work your way to the different sides, you get your different flows, and overall, most importantly, you find out which reality TV show you should go on to or who is your dream soulmate from a boy band. And, you know, we had so many choices with this kind of decision document service. We needed something like this to be able to branch out those choices. So let's walk through the design of what we needed in this step function state machine. We'll start with the JSON input. So we wanted to pass in a unique ID and the URLs of the different documents. So these URLs could be present or they could be null. Next, we wanted to take advantage of parallel state. So that kind of bottleneck I was talking about before with all of the lambdas being called synchronously, we then wanted to run this all in parallel, that we could do those different checks all at the same time. So we move on, and in the parallel states, we can now use that choice operator. So you see the first parallel state here has a choice operator that says, is the passport URL present? Yes or no. Is the CSCS image present or is the NI image present? And overall, we're able to run those checks now in parallel. So now we needed to move on to what do we do in those kind of yes or no operations. And this is where we can start to take advantage of that pass state. So if it doesn't exist, we can just put a pass there. And what that means, it means it's kind of just the end of the execution within that choice. It doesn't mean it goes straight to the end and everything's finished. It is just finished for that one iteration of choice, but still for the parallel state, it'll wait to everything kind of within that yellow dashed box is finished processing before we move on to the next state. So each lambda is set up, sorry, I'm maybe blocking this, but each lambda is set up to return the exact same response. So they will return if that document was overall valid, true or false. They'll return any validation errors from that document. So that could be things like, was the expiry date unable to be read? If the reg number maybe wasn't the right length or anything kind of like that. Then we also return the first name and the last name from the document. So as I said, with the parallel state, it waits till everything has processed within those different branches. That might be 3 lambdas have invoked, maybe only 2 of them, maybe only 1 of them. And something cool that you can do is use a results selector then to really transform whatever format you want that data to be in. So what I had set up, and I will show you the results selector in a few slides' time, but I set it up that all of the results, how many ever there is, would go into an array, and that array would then get passed into this compare results lambda at the bottom. And the way we set this up was to allow this to scale. Who knows, in 5 years' time, we could be supporting 50 documents here, and we need to try and figure out a way that we're not always editing this every single time we have a new document to support. So it takes in this array, it loops through however many objects are in it. If everything comes back that it's valid, we know, okay, all documents pass their checks. Let's take all of the name objects. Let's do a continuity check, make sure they're all for the same user. If there is some things that are invalid coming back, then we need to start looking at those validation errors. Let's group them all together. Let's return a list of what all failed and why it failed. So I'm going to just show you a bit of a demo of our step function state machine. Again, I've used dummy data, so the different documents do fail. So you can see here, once it's being processing, it will be in blue, and anything that has succeeded or finished will be in green. Oh, actually, don't think I've pressed play. Yeah, that's it now. So you can see this one has skipped the national insurance number. It wasn't present. You can see the CSCS check is coming back, that it was unable to read the reg number, that it's not valid. Passport is still in blue, it's still running, and you can see it hasn't moved on to compare result because it's still waiting for the parallel state to finish for passport check. So as soon as we see that it is passed, it's pulling the first name, the last name, giving us back those validation errors, and then overall, it's going to call that compare result at the end with all of those outputs. And you can see it all failed. They weren't real documents. And yeah, it's just a bit of a summary of even just that visualization, being able to see that has been extremely useful for debugging. The fact that you can click on to any of those boxes, view the input they got, view the output. It's a really just visual way of seeing all of that complexity that we were kind of hiding behind that one Lambda function. So you might be thinking, how do we build these state machines? And I've kind of just got a few slides on some tools that I found useful when we were doing this. Number one is the data flow simulator. So whenever you're moving the state between the different flows in the step function state machines, it's hard to try and work out the different results path, the input path, how you can select maybe some of your key value pairs to move on to the next state. And this is such a good tool for just experimenting and understanding how you can maybe select 3 keys from one object and send that to the next or transform it in any way. It does things like your state input, your input paths, parameters, task results, result selectors, result path. And here's just a bit of an example of result path where you can see that you're passing in a path, you can see how it's modifying it, you can view the results. And overall, just a really good experimentation tool if you're new to it and you don't really know how that syntax is working yet. I just think it's been really good to play around with and get stuck into. Then in terms of actually developing the state machine, we have deployed all of our lambdas using SAM as our infrastructure as code. And with SAM, when you're creating a state machine, you can pass in a JSON file as your definition. So this is written in ASL, which I found confusing. I thought it was American Sign Language. It's actually Amazon's own state language. Of course, there's another acronym, but you're able to write this, and with the VS Code AWS plugin, you can actually start to visualize what the state machine looks like. So if you've written maybe the wrong block and the branch is maybe nested and it's not where it's meant to be, you can view that straight away, which just makes it so much easier to build and just gives it that visual aspect and allows you to spot errors really fast before you hit that deploy button and cause chaos. So what are the benefits we have seen from moving to use step functions? Number one is just that reduced application complexity. Yes, our system wasn't technically broken, it was still working, but going into that Lambda, it was becoming a bottleneck, it was more complex to update. This way, it's a lot more simplified, it's a lot easier to view. And then also the reduced time of running things in parallel. Knowing that we don't have to synchronously wait if we did have 10 or 20 documents in the future for each one to process really just brings down that time for someone to actually get onboarded. And lastly, debugging has been made so much easier. The way we trigger this, we would put our worker ID and a timestamp in as the execution name. And it means if we ever get any issues, we can search for a specific worker, and we can then just at a quick glance like that video, say, okay, well, they've only uploaded 2 of their documents. We can click in, we can see the output for those specific documents, and we can debug really fast. Previously, we would have had to go into their profile, try to figure out what images they uploaded. We would then go into Lambda. We would then get the CloudWatch logs open for every single Lambda that triggered, match up the timestamps, try to figure out what time zone we're working with. There would have been a lot to do. Whereas this, you've got that visual aspect. You can just click into those different states and you can view those outputs, which has saved a lot of time. Moving on to some future plans, and this one's quite an exciting one. Using these step functions has honestly decoupled this whole kind of document validation service so much from our main job matcha logic. And the customer's even just seen doing document checks, and especially that continuity check at the end, is something that's useful for them, but also other people. So they have decided to partner with us on putting this on the AWS Marketplace as a SaaS offering. So we had to change our step function state machine a little bit to deal with this. I'm sorry, I don't know if this is the best quality to see, but you can see before the parallel state, now we do a DynamoDB lookup. And what we do here is if a customer was to register, they'll give us an endpoint for their application, and it's more of like a webhook integration. We can pass that endpoint the whole way down to compare result. Once we have that result, then we can reach out to their application with if the documents were valid and if they were invalid. So overall, working with step functions has really, really helped us. There's a lot of benefits in terms of reduced times and also debugging, but having this as a business opportunity is honestly such an added bonus. So overall, I hope you're able to learn something from this today. And I kind of just wanted to leave with this. Businesses and customers are always growing and changing. So our success really does lie in the adaptability of our architectures, ensuring that they can remain flexible to allow us to continually enhance them. So thank you all so much for listening to this talk. I have linked my X, my LinkedIn, and my personal blog website. So if you're interested in hearing about any more of this project development, maybe I can come back and tell you how the marketplace launch went eventually. But yes, feel free to connect with me on them. And I don't know if I'm over time or under time. If there's time for questions, happy to take them. Yeah, just let me know.
Yeah, you had a screenshot showing manual tests tool for it. Can you run automated tests against those step functions, or are you relying on manual testing to make a change?
So kind of a mix. We do for each of the individual lambdas, we have their own unit test suite within them. And then as part of our kind of full integration suite, we do trigger, we have like a test set of documents that we run through that we'll trigger at that point and make sure that they run and go through the whole system to test it. So it's not really specific to the state machine itself. It's more so just a full integration suite that we have that would run through every layer of the system.
Oh. A quick one just on the scaling aspect of things. I don't know what you apply but through that step function. Have you ever found that due to the locations of that state machine, have you found that it's either slowed down as a step function or step function execution overall, or one of the different bits of lambda become bottlenecks and we have to apply specific performance enhancements like division concurrency or something on lambda versus kind of any kind of performance enhancements around the step function overall?
Yes, we're not quite at that scale yet. We haven't really seen any of those kind of bottlenecks, but it is something we do have monitoring and alerting in place for those individual lambdas to ever see if we're reaching maybe our timeout state in them. If we need to look into something like that, having provision concurrency for them set up, that there's already a few warmed up and ready to go. A few of them might even have their own branch dates in the future. I know we had the passport one up there, and in the future we might even branch that even more to have different flows for different types of passports to go through it. So there's definitely still a lot of enhancements coming there, and that kind of monitoring and observability, which I think Mark is going to be touching on next as well, is such a key part of that to make sure, because I know we spotted that one bottleneck, but you're right, as this scales, there's a lot of moving parts now, so it really is making sure that we're observing at every single level of that and maintaining it. So yeah, sorry, it's a work in progress, not an exact answer.
Hey, great presentation, and it was really well presented. So that it looks like very simple, achievable. I guess like how long was the project? I'm sure it wasn't just like a really quick thing. How long did it take? What was the time?
It actually, doing the transformation to using the step functions didn't take too long because we didn't really have to change any of our individual Lambda logic. So all of those individual checks we could use as is. It was really just kind of changing that whole document validation part of it. I think it took us around 3.5 weeks to do the whole switchover, which isn't too bad. It was just making sure, like a thorough set of tests, and at the end of it, that everything was working and in order. But it really is just being a serverless orchestration tool. It was taking those serverless products we were already using and just allowing us to kind of control the mapping and the state between them. And that tool that I showed just around the result selector, I feel like that was probably the hardest part for us, just trying to work out how do we pass state through them, what format do we want that kind of data to be in, do we want to transform it at any layer. So if you are looking into it, I would definitely check out that tool. It really helped us just kind of get our heads around how that worked.
Did you use AWS during this, or was it only in the marketplace that you spoke to them and they helped with the design?
Yeah, well, I actually hadn't interacted with them before, but now just when we're kicking off that kind of marketplace integration, we haven't actually put anything on the marketplace before, so this would be a first for us. So definitely if there is anyone who has done it, would definitely love to grab a chat tonight and learn from you. But yeah, we're just at that point now where we're starting to engage with them a bit more, understand how we would do this, what that launch would look like, and just kind of get all of those kind of ducks in a row and lined up. And, you know, that could be the next talk whenever it goes live of how that went.
Yeah, for sure. I mean, I thought that was a brilliant talk. I love your slide about the evolutionary architecture and taking that solution and evolving it into a separate thing.
Yeah.
I mean, that's just perfect. And I mean, that's the nice thing about the way we're building. You can see an opportunity like that and evolve it into a brand new product, and then something like Marketplace gives you a massive platform. So I think that's super exciting and brilliant piece of work. So I just want to embarrass you for 2 seconds. So let's give Chloe a quick round of applause. That's brilliant.
Thank you.
Thank you.